Review, and this is part 1. It's the review for the final. So remember, you're supposed to be taking notes and reminding yourself of all of the things that we have done this trimester so far. So the first thing that I want to remind you that we did is we worked with integers. And we work with integers every single day. Okay? And one of the things that we looked at was we made a little chart, and we said we had counting numbers, which were numbers like 1, 2, 3, all the way to infinity. And then we had whole numbers. And whole numbers are counting numbers plus the 0. Okay? And then after whole numbers was integers. And integers means your negative numbers, like -3, -2, -20. Okay? All the way to the positive infinity. Okay? And then after integers, we have what we call rational numbers, and these are your fractions. Okay? And your fractions could be something like 1/4 or 0.25, or it could be something like 1/3, which is 0.333, repeating. Okay? So these rational numbers are repeating decimals, or they are terminating. And that's very important to remember, because we also have that little subgroup. And remember, our little subgroup of irrational numbers is over off to the side. It's part of our real number system, but they're not rational. And rational are repeating decimals or terminating decimals. But irrational are things like the root of 2, which never ends. Okay? So as a decimal, it never ever ends. Or pi, which never ever ends. Okay? So irrational numbers are non-terminating, never ending, and non-repeating. So it's the opposites. Okay? So if these guys are repeating and terminating, then your irrationals are the opposite. Non-terminating, non-repeating. And so when we looked at integers, we're talking about this group of numbers. Okay? And we had to be able to add them, subtract them, multiply them, and divide them. So let's take a look at what that looks like. If you are adding integers, okay, then you are doing things like -9 plus 13, which gives you a +4, because these guys are different signs, so you actually subtract, and then you keep the sign of the largest number, and this 13 is the larger number. Okay, or we also did subtracting integers, but what we found was that in algebra, we don't actually subtract. We say, we don't subtract, we're going to add the opposite. Okay, and when we add the opposite, this now is a negative and this is a negative, so I'm actually going to add them. And 13 plus 9 is 22, and because they're both negative, this stays negative. So we had some rules. We said if the signs were the same signs, then you're adding, and you keep the sign. But if they were different signs, then you're really subtracting, and you keep the biggest sign, or the sign of the biggest number. Okay? And remember, we never add, or we never subtract. Never subtract. You always want to change it to addition. Okay? Always do the change to addition and change the sign. Okay? And that way then you can follow these rules, because all of our rules are based on the addition of integers. Okay? And now we had multiplication and division of integers. And to help remind you, we learned that a positive number times a positive number gives a positive number. And a negative number times a negative number gives a positive number. A positive times a negative, or a negative times a positive, they both give negatives. So if we have numbers like 2 times negative 3, we're going to get a negative 6 because this is a positive and this is a negative. And a positive times a negative gives us a negative. So my answer was a negative. Okay, or if I had a negative 10 times a negative 6, I have a negative times a negative, and a negative times a negative gives me a positive. So my answer should be positive 60. Okay, that might be hard to read, positive 60. Okay, and we apply this every day. In every problem that we do, we have to remember the rules of adding, subtracting, multiplying, and dividing integers. Okay, well, it got a little harder, and we had to follow GEMDAS. And we have to follow GEMDAS every day since. We always have to use GEMDAS. And remember, G stands for your grouping symbols. Things like parentheses, brackets. It could be a fraction bar, like a division sign. You have to do the numerator before you do the denominator. You have to solve them both separately. It could be absolute value signs. Okay? It could be radicals or square roots, which we learned last week. And then you have exponents. Then you have multiplication and division in a left to right fashion. And you have adding and subtracting in a left to right fashion. Okay? And we got problems like 3x plus 2 times the quantity of x minus 3 is equal to 17. And we had to solve for x. So we have to first take care of our parentheses. Well, there's nothing that I can do on the inside. I'm not allowed to add an x and a negative 3. So in order to get rid of my parentheses, I have to distribute my 2. So I'm going to end up with 3x plus 2 times x is 2x, and 2 times a negative 3 is a negative 6 equals 17. And now I'm going to combine my like terms. And my like terms are this 3x and 2x, which makes a 5x, plus that negative 6. And now I have to get my x's on one side and my numbers on the other. So I'm going to move this 6 by adding the opposite. When I add the opposite, I've made a 0 pair. So I'm left with 5x is equal to, and 17 plus 6 is 23. Now to get my x all alone, I have to divide by 5. If I divide by 5 on one side, I have to divide by 5 on the other. And so x is equal to 23 fifths. And I can leave my answer like this because it's a simplified fraction. Okay? So my answer to this problem is x is equal to 23 fifths. Now, one of the things that they made us do was they made us learn the properties. And every time we solved a problem like this, we have to be able to tell what property it is. So to go from this line to this line, I used the distribution property. Okay? And then to go from this line to this line, I did this right here. I added my 3x and my 2x, so I simplified. Or sometimes you could say you used GEMDAS, okay? And then to go from this line down to this line, I added that 6 to both sides. So I used the addition property of equality. And it's also called the additive inverse. Okay, because I added the opposite to make that 0 pair right there. So I used the additive inverse property. And if I did it to one side, I did it to the other. So that was the property of addition, property of equality. Okay, and then when I did that, I got this line. And so really all I did was I made that 0 pair, and then I combined 17 and 6. And so that was a simplify step. And from this line down to this line, you can see I'm dividing by 5 on both sides. So that's the division property of equality. I did it on both sides. And it's also making a form of 1 here. And when I make that form of 1, I was using the inverse property of multiplication. The inverse property of multiplication is division. Okay? And then to go from that place down here to my answer, I simplified. And so remember that you're going to have to use your properties to justify your steps. And so you can find your properties in your cheat sheet because we did a big activity on all the properties that we've used so far. You can also find them in the back of your book on that page that had the properties listed. Okay, so you're going to want to remember those. And then one of the other things that we did was we had to plug numbers in. So if we were given something like this, and A was a -1, and B was a 2, and C was a 3, we had to plug them in and solve the problem. So I have to take my B and I have to say, all right, it's a 2. So I'm going to plug 2 in and square it. -4, and A is a -1, and C is a 3. And now I have to solve. But because I never subtract in algebra, I'm going to rewrite this to adding the opposite so that I can solve. And now I'm going to do my exponents first, and 2 squared is 4, plus, and now I have to do this piece, -4 times -1 is 4, times that 3. I have to do my multiplication first, so I'm going to write my 4 plus, and 4 times 3 is 12, and 4 plus 12 is 16. Okay, and so this was combining multiple things. We had to use GEMDAS, we had to substitute in, we had to show our steps, and they may say to you, justify your answers, okay, using the properties. So make sure that you can do that.